Hi everyone, I've been asked a few times about how GPS works. I've done a few GPS YouTube videos, so I thought I might try and attempt to do one on how it works. Very overview, not very detailed, but give someone a bit of an idea of how it works. There's probably a lot of videos on YouTube and explanations around the place, but thought I'd give it a crack. So I'll move into the garage and set up the whiteboard and see how we go. Welcome back. Following on from my other GPS videos, I thought I would just add a one on how GPS works. We often use these devices quite a bit, adventure riding, four-wheel driving, just generally they're in phones, in tablets, they're in everything, and it just works, and everyone probably just doesn't realise what's going on behind the scenes. Quite complex maths and some quite complex hardware involved to make that work, and it's unbelievable they can get them down to the prices they do these days. These are commercial GPSs. Depending on what variety of this sort of GPS you get, this could be up to $20,000 or more. This one here is probably a bit less than that, slightly less than $20,000. Another type of commercial GPS, this one has a radio in it because it can get 2 centimeter RTK corrections, but no displays or anything on these. They just output the information needed for a system. So then we come back to our smaller. This is a commercial, semi-commercial Bluetooth GPS. You can also add an external antenna, but it has an antenna built in, and you start that up and you can Bluetooth it to your phone or Bluetooth it to a display like this one, or Bluetooth to this display, and this can actually take GPS corrections, which can make this more accurate than the standard GPS accuracy, which is about 3 to 5 meters. And then there's the ones that a lot of people see, the HEMAs and the mapping displays. So that's what that one there is. So how does it work? I'll try and simplify it as much as possible. I'm not a super duper expert on this. The key to GPS and its accuracy is measurements and timing. And so up in the GPS satellites there's atomic clocks, very, very accurate atomic clocks. Down in the user device there is a very accurate quartz clock. Nowhere near as accurate as an atomic clock, but obviously you can't carry an atomic clock around in your GPS. They're big, they're heavy, they're expensive, and full of things like uranium. So what they do is they send out a timing signal from the GPS satellites down to the end user, and at the same time the exact same signal is being developed but generated inside the receiver, and they basically look at the offset of that to work it out how far away you are from the satellite. So there's a signal being generated by the GPS satellites. It might look like that. It's called a pseudo-random signal. So it's a certain pattern, and exactly the same pattern is generated from the handheld GPS, and I'll try and match that. Not quite right, but what they do, they work out the differences between once the signal is put back together, how far this is from the GPS satellite, this is in the user, and the offset of those two signals is how long it took for this signal to reach that handheld, and that's how they do the timing. A really amazing thing is that this signal is actually less usually than the surrounding environmental noise, and they use some very clever maths and statistics to work out what that signal is under the noise level, under the noise floor. So that's how they work out the timing. So once they've worked out the timing, they've got to be able to work out your location. So now they know the time. So how that works, it's called trilateration. Trilateration, and you can look that up on Wikipedia or a website. So how that works is you've got to remember that all this is one-way communication. So there's no sending a signal and getting it back. It's all one way. That's why the timing offsets and having clocks in both is important. So you can imagine is if you could think of the 3 satellites as 3 towns. So if you had 3 towns, we'll call them town A, town B, and town C, and you said to someone that you were 50 k's away from town B, and you drew a circle around that, you could be anywhere on that circle. So someone would have to go out to that circle and walk around a circle to be able to find you, and they would run into you at some point. But if you then said, I think I'm also 50 k's from town A, so now as you can see, if you're 50 k's from A, 50 k's from B, you can only be at these 2 points. So you've cut down all the other points on the map of where you can be. So if you said you were 150 k's from C, if we do 150 k's and drew a circle, and that goes off, you can see all 3 intersect at that point. So that's the only place that you can be, is that point. And that's effectively the same as what 3 GPS satellites are doing. Depending on where they are in the sky, they'll use this exact same method to work out where you are on the Earth. And that's called trilateration. So very simple fundamentally, very complex in actual execution.